Hello everyone. In this video, I introduce the solution for Leetcode weekly contest 342. There are 4 problems, and the difficulty is 2, 3, 4, 5. So generally, this is not a very difficult contest. And we start from the first one. The problem is like you will get 2 values called arrival time and delete time. You should return the sum of these 2 times, and the only tricky thing is need the result in 24 hours format. That means you need a model by 24 for your result. So this is the only tricky things for the first problem. Generally, this is a very easy problem, and we go to the second problem here. The problem is like you will give a positive integer n, and the problem need we find the sum of all integers in range 1 to n inclusive that are divisible by 3, 5, and or 7. So we need to check the range of n is 1000, not big. Then this solution is quite direct. Like we just iterate each number in the range 1 to n and check whether the number is divisible by 3, 5, or 7. If it is divisible, then we just add the value to the result and then return this result. So this solution is quite direct and simple. And here we go to the third problem. This problem is a sliding window problem. Then we will get an integer array called nums, containing n integers, and find the beauty of each subarray of size k. So k is also a input parameter. And also, we need to check what is the meaning of beauty of a subarray. It means the axis, smallest integer in the subarray, if this axis smallest integer is negative, or we return 0. So this is based on subarray, right? So for each subarray, we need to have a result. Then totally, we should have n minus k plus 1 integers in the result. And we should return this in a vector. Okay, so for this problem, if we check the constraints, we can see that the number actually is very small. It's not. It's in a small range. It's just minus 50 to positive 50. So for this problem, the solution can be simple just because of this constraint. Like such like we can use a map. The map's key is the number in this array, and value is the count of the number in the current subarray. And we can just iterate this array from the first elements to the last elements. And here we just calculate the count of this number in the current subarray. And if I is still less than k minus 1, means we still not get enough elements even for the first subarray, then we just continue. And if I is bigger than k minus 1, that means to calculate the count of elements in current subarray, we need to minus the elements in the previous subarray. So we just minus this is the elements of the previous subarray that are not in the current subarray. right? So we just minus its count in this map. Then after this, we just iterate the numbers from minus 50 to 0, actually to minus 1, and calculate and accumulate the count into this variable. And if this variable is bigger or equal than x, means we already get the x's smallest number in a subarray. And in that case, we just push the value into the result vector. And if we already loop all of the minus numbers in the array, in the range, and we still not get the expected result, that means the x's smallest number is not a positive number. So we just put 0 into the result vector. And finally, we return the result vector. So this time complexity is 50 by n, and the n is 10 powers 5. So generally, the time complexity is acceptable. So one question like, how about if this range is very huge? Then in that case, I think maybe search tree or binary search tree may be a good solution. So what do you think? If you have any ideas, you may leave a comment to me. But currently, I feel we may use the binary search tree to resolve this problem if this range is huge. In that case, the time complexity can be n by it should be n by log k. Okay, next one, and also the last one, is the first problem. The problem is we will get a indexed array nums consisting of positive integers, and we can do the following operation on the array any number of times. The operation is we select the index I, and we replace either of numbers I or numbers I plus 1 to be their GCD value. And when we stop operation, we will need all of the elements in this array to be 1. And then we need to return the minimum number of operations to make all elements of nums equal to 1. If this is not possible, then we return -1. And we can check the first sample to see how this works. For example, I can calculate the GCD value for 3 and 4, and their GCD is 1. And here I replace the third element with 1. And the next one, I calculate the second and the third elements GCD and replace the second elements with their GCD 1. So the array becomes 2, 1, 1, 4 now. And then the next one, I replace the first element with GCD 1. And it's become 1, 1, 1, 4. And the last one, I change the first element to be GCD of 3 and 4, the third and the fourth elements. Then finally, it's become 1, 1, 1, 1. And these are need 4 elements. And for the second example, that we cannot really change these elements, all the elements in these nums to be 1. So it will be the result will be -1. Okay, so for this problem, I think it need a little explanation about how this works. So for example, we have the elements is from 0, right? So if we have 0, 1, 2, 3, 4, 5. For example, we have 5 elements in the array. And the first observation is if we can change or if we already have elements of the array to be 1, then 1 with any value, their GCD is 1. So that means we can change any elements adjacent with 1 to be 1. Such like we can change the left one to be 1 next time, or the third one element to be 1, because their GCD, no matter 2 and 3 or 1 and 2, their GCD definitely is 1 because second element's value is 1. So the key is we must have at least one element that can get value 1. And if we already have this as 1, then I think the problem is easy, that we just change its adjacent elements to be 1 the next time, and so on and so on. And another problem is, how about if all elements are not equal 1? So here we may give a example like, for example, this is the first element 4, and the second element is, for example, is 6, and the third element is 9. Then for this problem, so we don't care about what is the value of the fourth and the fifth elements, and also don't care about 0. We just check how can we change one element of 1, 2, and 3 to be 1. So we check that the GCD of 1 and 2 elements, their GCD is 2. And the second and third element GCD, this is 3. And we must calculate the GCD again between 2 and 3 to get 1. So what we can do is we can change the second element to be GCD of 1 and 2 the first element and the second element. So we change it like 4 and change the second element to be GCD 4 and 6. Then it should be 2 here. And now the third element is still 9. And the next time we will change either the second or the third element to be GCD 2 and 9. For example, we still change the second one to be GCD 2 and 9. Then here we can get 1, and here is 9. So that means we need to do 2 operations here, right? So the problem actually, it means the problem should be it should be resolved in this way. So for these elements in the array, we must find a subarray of the array and get all of these elements in the subarray to calculate their GCD. If their GCD is 1, that means we can, for example, for a subarray, there is a, for example, k elements here. And if the GCD of all elements in this subarray equals 1, then that means we need k minus 1 operations, because we just calculate the 2 elements in the subarray and change the later one to be the GCD of the 2 elements, and the next one we will calculate these elements with each adjacent elements, and then set the next element to be GCD of their of the GCD value. and so on. So it means we need a k minus 1's operations to set one element of the subarray to be 1. And based on that, we still need n minus 1 operations to change all of the other elements in this array to be 1. So if we get this subarray k, then the answer should be k minus 1 plus n minus 1, right? So here we come back and we check the array's length is just 50. So this is quite a small array. Then what we can do is we can just iterate each of the subarray in this array and calculate whether their GCD is 1, and then use the form we get here to calculate the result. So the total solution looks like this. First of all, we check whether any number of the array is already equals 1, and this is the number of ones in the array, and if this is bigger than 0, actually it just means n minus number of 1 operations to change all of the elements in the vector to be 1. Otherwise, we iterate. So here we iterate each subarray in this array, and we calculate their GCD of the array. It looks like it just looks like, for example, I start from the first elements, and then I calculate the GCD, first one and the second one. And if this is not 1, then I calculate this GCD's value with the third one, and so on, until I get a GCD equals 1. Then I can stop here. Because this is the smallest subarray, I can get their GCD to be 1 starting from the current elements. So that is how this iterator works. And if we get their GCD equals 1, we just use this theorem to calculate the result. And if the answer still equals minus 1, or the answer is bigger than temporary answer, I update answer to be temporary answer. And finally, after all of these iterators comes out, then I return the answer here. Okay, so these are the solutions for the Leetcode weekly contest 342. Thank you.